Hello everyone, this is Sachin from Shiksha Anusthan. In this video, we will be doing topography. The term topography has been derived from two words, topos and grapho, which means to place or to draw an object or depict. Respectively, thus a topographical map shows the surface of the earth in detail. The topographical maps are also known as ordnance survey maps, and these were drawn generally by Britain in the army for the army by the Surveyor General, every country prepares these maps, and in India, ordnance maps are published by the Survey of India Department. There are the rules. Now coming to, let us know the directions. General there are four directions: north, south, east, and west. And as you can see in the figure, and there are some sub directions within these four directions. These are north, east, southeast, southwest, and northwest. Now let us go to details. What are the scales of map? A map represents the features of the surface of the earth in a miniature form. Hence, a map needs to be drawn to scale to depict the features of the areas it represents. We can't place the whole actual representation of the earth in a small piece of paper. So we scale the whole actual representation into a smaller scale, and we draw it in the map. The scale of a map denotes the proportion that the distance between any two points on the map bears to the distance between the same two points on the surface of the earth. The scale is also defined as the ratio between the distance of any two points on the map and the actual distance of the same points on the ground. It can be expressed as map distance between two points by ground distance between the same points. And there are generally three methods of representing a scale, but we'll be going through only two important methods. One is linear scale. The scale is represented by a straight line divided into equal parts, as you can see in the figure, primary and the secondary, to show what is marking represent the actual ground. The primary division are the major divisions of the scale, graduated from left to right. From left to right. And the secondary divisions are smaller units graduated from right to left, as shown in the figure. The total length of this linear scale represents a distance of 25 kilometers. Each primary division denotes a distance of 5 kilometers, and each secondary division denotes a distance of 1 kilometer on the actual ground. 1 kilometer, and this is 5 kilometers. So this scale gives a proportion of 1 is to 1 lakh, which means 1 centimeter here on the map is equal to 1 kilometer on the ground. Then coming to the second scale, that is the representative fraction or RF scale. This scale is represented as the ratio of the length of the line of the map and the corresponding actual distance from the surface or the earth surface. The numerator is always expressed as unity, or one unit map distance is equivalent to number of unit of ground distance. The distance of map by distance of ground on same unit. Most important point in a representative fraction is that the unit of measurement distances of in the numerator and the denominator is same. For example, if RF of a map is 1 by 1 lakh, which this means or 1 is to 1 lakh, it means that 1 unit on map represents 1 lakh units on the ground. If the unit is centimeter, then 1 centimeter on map represents 1 lakh centimeter on the ground. So similarly, so as I said, 1 centimeter is to 1 lakh centimeter. So this 1 centimeter on the map is equal to 1 lakh centimeter on the ground, which means 1 kilometer. So 1 centimeter on the map represents 1 kilometer. Now let us see some questions which might come in calculation of the scale. If a scale is 1 inch to 4 miles, what is the representative fraction? Mark it on a scale line. So as we know, the formula for representative fraction was distance on map by distance on ground. So 1 inch by 4 miles, so 1 inch by 4 into 63,360 inches. So as 1 mile is 63,660 inches, so it comes to 1. So the result comes 1 is to 253,440. And on drawing this on the linear scale, we get the figure like this: 4 miles and 4 miles, 8 mile distance, and here this is 4 miles on the map. Now, if the RF is 1 is to 1 is to 5 lakh, then convert into the verbal statement. See, 1 is to 5 lakh means 1 centimeter to 5 lakh centimeter. As we know, 1 kilometer is 1 lakh centimeter. So 1 centimeter to 5 kilometer is the actual verbal statement of this representative fraction. Okay. Now let us go to contours. What is a before knowing the contours, we need to understand some important parts of the contours. What are the parts? The first one is vertical interval. We call it in short form VI. You can see in the figure these vertical intervals in between. It is a vertical distance between any two contour lines. We can say if this is a contour line and this is a contour line. The distance between this is a vertical interval. The vertical and it is either 50 to 100 feet. In 1 is to 50,000 survey seats of India, the contour lines are 20 meters. These are 20 meters. In Indian survey map, these are 20 meters. Then horizontal equivalent is the horizontal equivalent, as you can see in the figure, HE. It is represented as HE. Then gradient. What is gradient? Gradient refers to slope of the land. It determines the steepness of slope, and it is a ratio between the vertical height and the horizontal distance. Vertical interval by horizontal equivalent. For example, if a gradient of 1 is to 5 means that for every 5 units of horizontal distance, there is a rise in 1 unit in vertical distance. This is rather steep slope because for 5 it is 1. And if on the other hand, if it is given 1 is to 50, this indicates that the slope is gentle because every 1 unit of vertical rise, the horizontal distance is 50 units. Okay, now let us get into details for slopes. The first type of slope is flat low-lying land. It consists of areas within elevation between 20 meter to 40 meter above sea level. Such areas are suitable for agriculture and have sufficient slope for natural drainage. Then undulating slope. It is also known as irregular slope. It changes after short distances. Some part of this slope may be convex, whereas some part may be concave, and this gives a wavy appearance. Therefore, the contour representing the undulating slope are drawn on irregular distances. Then gradual slope. In such a slope, the change of elevation is gradual. Normally, 1 is to 25 gradient is called gradual slope, and the contour of such slope is placed wide apart, as you can see in the figure. They are wide apart. Then uniform slope. When a rise or fall of a ground per unit horizontal distance is same at every point, it is called a uniform slope, and the contour showing a uniform slope are drawn at equal distances. Then steep slope. When the land suddenly slopes up or down, it is known as steep slope. In a steep slope, the contours are drawn close to one another. Okay. So as you can see, some of the examples of contour, it is a conical hill. You can see the smaller one, the first height in the between is 700. This one represents the tip of the mountain, and the last one is 200. This one represents the bottom of the mountain. So we can see the 700 to 200. This is the steep one. This mountain falls down steeply, and it is a steep slope. Then coming to V-set valley, you can see this is 800 meter. The middle part is 800, and the above one is 1200. This above part represents this above land, where this middle part, the 800 meter represents the deeper or the depth of the valley, deeper part of the valley. Now coming to plateau region, the above one here you can see is 1200 meter. This one represents the plain, whereas this 1500 meter represents the top of the plateau. Now to some important parts. These are generally asked questions to represent what does this height represent, what does this spot represent. So the first part is here. These are called marked heights, and the first one is spot heights. It refers to the height of a point above a ground, on the ground above the mean sea level. It is indicated on a map but not on ground. It is represented by a dot followed by a number. If you write dot 8, if you write dot 8, this is known as spot height. Dot 8, if you write dot 8, or if you given dot 9, so this represents a spot height. A spot height gives the information about the height of a specific point only. It gives no idea about the relief features like mountains, plateaus, etc. It only gives an idea about a specific point. Then comes triangulated height. When the point has been accurately surveyed, the dot is enclosed within a triangle. When the point is accurately surveyed, the dot is enclosed in a triangle, And this is if it is given triangle 900, this means it is triangulated height. Um, and all this triangulated height is also known as trigonometrical heights. And the height of such a point is called triangulated height and determined trigonometrically. For example, the mountain peaks. This generally represent the mountains and all. Then the relative height, it is written with a, this is followed by r. You can it is written all 8r, 2r. In areas such as steep slope, the difference between the maximum, this is the relative height, is the difference between the maximum height and the minimum height, which indicates the relative height. Thus, if one finds R3 written on a slope, this means that the place is 3 meters higher than its neighboring place. And if it written 8R, then 8 meters higher than the neighboring place, 2R, that means 2 meters higher than the neighboring place. Then coming to benchmarks. These marks etched on a stone or a stone on building to indicate the accurate height determined by surveys. They serve as a reference for surveyors. On most ordnance maps, benchmark is written as BM, capital B and capital M, the dot, capital M, and followed by a number. The number indicates the height of the surface level at a marked point. If it is written like, for example, B dot M 25. So this is the height 25 meters above sea level. So there is a difference between the spotted and the benchmark. Spotted indicates only the height of the ground above mean sea level, whereas benchmark indicates at some point marked above the ground and includes the height of the object on which a benchmark is etched. This benchmark includes the height of the object on which the benchmark is etched. Okay. Now let us know about the course of river. See, as you can see the contour, the contour gets reducing. So first the initial one is 1900 and the last one is 500. This means it is a slope. If the height of the place gradually decreases downwards. So if a river is flowing from a contour of 1900 to 500, this means the 1900 part of the upper course of the river, then the middle course, then the middle course will be somewhere in between the average height, that will be 1100 to 900 in the middle course, and then the lower course. And this generally helps, this contours also generally help in identifying the direction of flow of the river. So we need to be vigilant about it. Then coming to drainage pattern. Generally, there are 4 types of drainage pattern. One is dendritic, as you can see, it takes a dendritic form. Then one is sterilized. Here, every small stream gets comes and joins the larger stream. Then a radial drainage, where this is a highland or a plateau, and from here or a mountain, from here the rivers flow downwards. Then underground drainage. Here the rivers come and they disappear in between, and they again come out in some other part. This might be they dried out. They have dried out, or they might have disappeared into the land or into a cave, or in such a case. So let us know more about it. The dendritic drainage pattern, as it is mostly asked question, what is the drainage pattern? So we need to be thorough about it. So it is a branching tree-like drainage pattern, which is generally found on flat lands. Then terrace drainage pattern is a rectangular drainage pattern with streams flowing parallel to each other and joining the mainstream. It is generally seen in areas like alternating hard and soft rocks or a region of limestone. Then if we find a terrace drainage pattern, then we can be sure that there are limestone or soft rocks is nearby. Then a radial drainage pattern, it is generally a drainage pattern with streams spreading out in all directions like spoke of a wheel. It generally exists where the conical hill, volcano or a plateau exists there. Then disappearing streams, when rivers do not have enough water to reach the sea, they dry up or they disappear into the sand. They are known as disappearing streams and are indicated by dotted lines. The phenomenon is known as underground drainage. Then inland drainage, when the streams and rivers flow into a lake instead of a sea, they are called inland drainage. Okay. Now let us know of some of the color representation of the maps. Apart from the conventional signs different colors are used to show the distributional pattern of different land uses on the topographical sheets. The first color here we consider as black. Black is generally used to represent the names, the lines of latitude, longitude, surveyed trees, heights, the numbers, the river banks, broken grounds, railway, telephone line, telegraphs, etc. Blue color represents the water related features, of course, perennial rivers, However, minor non-perennial streams are shown in black. If a river is a non-perennial river, that is shown in black or dotted lines, or dried up river, is shown in black. Then green, forests dark green, grasslands light green, orchards, scattered trees and shrubs. Then white is rocky or badlands, open scrubs, uncultivated lands. Yellow is cultivable lands. Then coming to brown, sand-like features, sand dunes, hills, contour lines, form lines. These are shown in brown. Then red, eastings and northings are, as well as the numberings are also sometimes shown in, are also in red. And the man-made features such as road, cart track, building huts, they are also shown in red. Then coming to grid reference. A grid is a set of lines used to find the exact location of places on map. On an ordinary map or a globe prepared on small scale, you may easily find out the position of a town with the help of the grid formed by latitude and longitude lines. Topographical maps are large scale maps, so exact locations cannot be expressed accurately by grid latitudes and longitudes. The points at which the vertical and horizontal lines grids cross are called coordinates. See, these vertical lines in topographical maps, these vertical lines are called these vertical lines are called eastings. As you can see the numbers, they increase towards east. Then these horizontal lines are called northings. As you can see, these numbers increase towards north. And in a map, these eastings and northings they crisscross each other and they form a grid-like pattern. So, as most of you are having difficulty in finding this 4-figure and 6-figure calculations. Okay, so let us see how we can do it. Suppose a figure, suppose we have a tree here. Suppose we have a tree here, and in question is asked, find the 4-figure of this tree. So you can see what lines has it crossed. That is the northings here are 11, 12, the eastings here are 32 and 33. As you can see, this and while forming a 4-figure, when you first write the eastings, then we need to write the northings. As you can see, it has this tree has completely crossed the 32 line and is before the 33 line. So we need to take the 32 line as the correct easting. So we'll write in 32, and we can see that this line has already crossed the 11 northing line. So we'll be writing the 11. So the 4-figure comes out 32, 11. So remember this. You need to find out which easting line it has crossed and just crossed, and which northing line it has just crossed. So to get a complete square, that this is the complete square we get. This it crosses this part, and this is the square we get. So any object lying in this square part will have this 4-figure. Now, why do we got a 4-figure? To get a particular, more accurate measurement or accurate scale, we need to find a 6-figure. So, how to find a 6-figure? Okay. Now, let us take a same tree over. This dot represents this tree. Okay. So we see this dot has already crossed the 32 line and already crossed the easting and already crossed the 11 northing. So we know 32 and 11 is a sure, because this has crossed as per 4-figure. This has crossed the 32 easting line and this has crossed the 11 northing line. What we need more is it has crossed the 32 line, but how far has it gone ahead after crossing the 32 line, and how far it has gone above after crossing the 11th line? So how to find it? What we do is, if we take these two lines, and we break this line into 10 divisions, and we break this line into 10 divisions. Okay. So now, if you break this line, this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10, sorry. Yeah. Then here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So as you can see, this tree has this listing has already, this tree is in the as we found out that it has already crossed the 32 and 11. So 32 needs to come 3 ahead. 32, 1, 2 and 3 ahead to be in this part, and this 11 needs to be 6 above to be in this part. So the 32 needs to come 3 ahead, so we get 32 3 and 11 6. I hope it was clear. So to let us we'll be discussing this and solve this and solving a problem on it at the end. Please bear till then. Okay. Then calculating the area. On topographical maps, each grid square measures 2 cm to 2 cm or 1 kilometer into 1 kilometer, since 2 cm is equal to 1 kilometer. Therefore, the area of each square is 1 square kilometer. We can remember this. Most of the topographical maps are 2 centimeter maps or one, and we know that 2 centimeter is equal to 1 kilometer because the RF factor of this topography of Indian survey maps are 1 is to 50,000. So 1 centimeter is to 50,000. So it comes to 2 centimeter is to 1 kilometer. So the area of one square becomes 1 square kilometer area of this square in a topographical map. To find out a complete grid square within the area, what we can do is we need to calculate how many complete squares are there, how many half a quarter squares are there, how many squares all in total we have. So as you can see from figure, we have 8 complete squares. So each complete square has a area of 1 square kilometer. So the area comes of complete squares is 8 square kilometer. Then we have half number of half squares is 4. So area of half squares become 1 into 1 by 2 into 4 into 1. So it comes 2. Then the area of 2 by 3, number of 2 by 3 squares are 2. So the area of 2 by 3 squares comes as 1 by 3, and number of 1 by 3 squares are 8. So the area of the 1 by 3 square comes as 2 by 2.6. So if we add all these areas, and we get a total area of 13.9 square kilometer. Okay, now settlements. Settlement is a group of human dwelling in urban or rural areas. Thickly settled areas are found over fertile plains and over wide river valleys. Thinly settled areas are found over plateaus with poor agricultural land, in forest, on terraced mountains, over flat hills tops, in deserts with poor vegetation. Absence of settlements or empty spaces may be seen over marshes, swamps, inaccessible forests, steep mountain slopes, over areas of coastal flooding and sandy deserts. Now coming to the first type of settlement, that is linear settlement. Linear settlement houses are usually stretched out along the local road, river, canal or railway line. Linear settlements, also known as ribbon patterned settlements. As you can see, all the houses are linearly arranged along the road or railway lines, whatever going through the place. Then coming to dispersed settlement. Dispersed settlement or scattered settlements, it is a pattern of rural settlement in which the population lives in farms. Where the population is dispersed, some houses here, some houses over here, some houses over here, and the roads are also not in a proper shape. They run along the line and so on. This type of settlements is generally associated with regions of high land, poor soil, or abundance of available sources of water. This pattern is also associated with large farms and sparse population. These settlements are shown in survey maps, red squares over the wide area. Then coming to radial settlement. Radial settlement, in such settlements, houses are in star-like cluster, where the main part of the town or the square of the town is in between, and all other houses follow in this. You can see big cities like Paris and the New Delhi, they are in this pattern. In such settlements, houses are like star cluster around a tank, lake, factory. You can say that, and some industrialized cities are also such. Then nuclear settlements. Nuclear settlements, it is a form of rural settlement in which farms and other buildings are clustered together, often around some central feature like church, temple, or police chowki, etc. See, here you can see the police chowki is written as PS small. This is a mosque. This is police office. This is temple, and so on. And we can also identify the religion followed by the people of that particular area by identifying the temple, these religious monuments. And we can also find how developed the town is by identifying the police station. If it has a police station, it is more developed. If it is a police chowki, it is less developed. If you have a post office, it is a mode of communication, and so on. Now, the evidence of land use are shown by various symbols on topographical maps as follows. Open scrub, seep, and goat rearing. Stony waste is used for uncultivable land. Sea troughs, uncultivable land. Rock outcrop, it is uncultivable land. Broken ground, it is agriculture. Tanks, canals, etc., it is agriculture. Then some occupations and how can we find this that we can identify that people of the area have this kind of occupations. Okay, forestry. The people of the area depending on forest for their livelihood. That means that means a place where we will be having a forest or a green patch. If the people have agriculture as occupation, that means the area will be having yellow patch or orchards. That means they are doing agriculture. If these meadows or this scrub is there, then people are doing cattle rearing or cattle grazing or sheep rearing. If there are mines and quarries, then people are into quarrying or mining. If there is settlement near a road, port and river, road near main roads or ports and rivers, then they are doing their motor trade. If you find annual fair being organized, then it is a trade. Then factories and mines, then industrial development in the area, golf courses, park, rifle ranges, then entertainment and cultural development, coast, lakes, rivers, then fishery would be some type of occupations of the people that we can identify from the map. Here you can see some of the symbols and conventional signs for uh, identifying uh, some important parts of a map. As you can see, for fort, church, tomb, then uh, pagoda, graveyard, chhatri, uh, mosque, battlefield, temple, tomb, police station, rest house, circuit house, dark bungalow. Dark bungalow is this old post office. Then inspection bungalow, brick kiln, where bricks are generally made. Uh, then for roads, you can see metal roads means properly proper roads that are concrete roads, you can say. Then metal roads is sign, proper sign, backtracked to pass where the river is dried up and you can pass, or the cart track, you can say that. Then some bridges, causeways where the river dried up and you can pass on. Bridges without piers, bridges with piers. Then we can say the pontoon bridge, where this is not a permanent bridge. These bridges are on air balloon. These are made on air balloon. Then for railways, you can see the rail station, double Broadway gauge, single Broadway gauge, railway level crossing, cutting tunnel, single gauge, milestone. Then aerodrome, you can see the airfield, lighthouse, telegraph line, drainage stream, river with islands, tidal river, the symbol here. Then river with bed stream, dry river bed, river bank, canal, tidal stream. Then the dam, perennial canal, canal block, lined well, unlined well, dry tank, perennial tank. This is in black and white. The colors in your book will be given in color. In exams also will be given in color. This well means this will be blue in color. line will this outside this outer line will be in blue and the inner one will be white. Then dry tank. This is perennial tank means water will be there, blue water, completely blue will be there. Then tank with embankment means this has a boundary. Tank with water. Then brackish means salt water. You can say. Then spring embankment for basically this is palm trees, coniferous trees, grass, bamboo, shrubs, swamp, dense jungle, open mixed jungle. Then we can see reserved forest, protected forest, state forest. Okay. So and also sand dunes, fences, nuclear settlement, all we have covered. Then camping ground where people go for camps. Then we can say contours, front lines. Then the map towards north. Then the post office, telegraph office, post and telegraph office, the spot height. Then the triangulated height, benchmark, international boundaries, state boundaries, stony waste, street rock, rock outcrop, and all this things. And I have attached all the PDFs in the description, the links to PDF. You can get it over there. Okay, so now let's solve a real map. This is a G437 3S7 map downloaded from the map Survey of India website, and this is of map of Gujarat. So let's solve some important questions out of over here. Okay, so taking this part of the map to find the 4-figure and 6-figure reference of spot height 164 near Bhakar. Okay. So on zooming, we get the spot at 164 is here. Okay. So as you can see, this has already crossed the 87 northing and the 25 easting. So as we know, the easting is written first, so the 4-figure will be 2587. Okay. Now let us find the 6-figure. So you can see this is the the easting line, and this is the northing line. As the place has already raised to this much height, and we need to find this particular region. So what we can do is we can draw or we can divide this segment into 10 divisions. And this this is our because do a dotted line. So this is our our object that we need to find. So let us divide this in 10 divisions. On dividing, we get it. This is 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. See, I'm doing it roughly. You can use the scale for better measurements. Just to make you understand, I'm doing it roughly. In exams, better if you it will be advised. It is advised to you to use a scale to get the perfect measurement to make it to be 10 divisions. Okay. So as we can see, we got this. This is hitting the 8 line over here and the 9th line over here. So we can say that is 25 needs to be raised in line. So it will be 25 for 9. Sorry, it will be the 25 needs to be brought ahead till 8. So 25 to 8 and 30 and 87 to be brought raised to 9. So 87 to 9. So 25, 8, 87, 9. This is the 6th figure. Okay. So as you can see, this place also has some green trees. This is the spot height of 156. This is the main power line marked. This covered tanks.
Then this is some brackish water lakes, tanks, dry tanks. This is the spot. The triangle height is this is, that means this is a plateau or a hill region, and you can see the radial pattern of drainage over here, and some of the disappearing lines over here, and also the settlements are so you can see find temples over here. That means the place as a region of Hinduism. This has a track metal road over here. Uh, and this is well connectivity. This is some perennial source of river water over here, and so all this region also has as you find tanks and some river water line over here. This means this area has also has yellow in color. This is cultivable land, and yeah, so all these informations we can get from this small part, and in this short period of time, we can't cover all the parts of composites, and this is a huge vast concept. But I tried to give you a brief explanation about it. This can only be achieved mastery by practicing numerous times. And if any doubt and if you need some other help over it, please leave it in the comment. Please mention in the comment section. We will definitely try to cover it in upcoming videos if needed. Yeah, thank you.
Do like and subscribe our channel for more upcoming videos. Thank you for watching.